Imagine an ancient traveller born in a distant corner of the galaxy, wandering for billions of years through the cold emptiness of interstellar space. It has seen the rise and fall of stars, it has crossed through invisible rivers of radiation, and it has remained untouched by the warmth of any sun. For ages this frozen body drifted alone, silent, a relic of a world that may no longer even exist. And then, against all odds, it stumbled into our neighbourhood, the solar system, on a path so strange and so violent that astronomers instantly knew it was not one of ours. This was an outsider, a trespasser, carrying with it the fingerprints of an alien birthplace. They named it Comet Atlas, and its arrival shook the scientific world. What made it so extraordinary wasn't just its interstellar origin. It was the mystery it carried in its chemistry, in its speed, and in its dangerous trajectory. Unlike any local comet we've ever studied, Atlas revealed a strange dominance of carbon dioxide, a composition unlike the icy wanderers we've tracked for centuries. To many, it was as though we were peering into a chemical time capsule, a frozen shard of a planetary nursery far beyond our sun. And yet this shard was heading straight for one of the most treacherous regions of space, the asteroid belt. The moment astronomers calculated its path, excitement quickly turned into tension. The asteroid belt has always been painted as a graveyard of shattered worlds, a cosmic obstacle course of tumbling rock and dust. But Atlas wasn't just passing through, it was plunging against the flow of traffic, moving in the opposite direction of nearly every asteroid it would encounter. To survive, it would have to thread a needle through billions of spinning fragments. One wrong encounter, and this ancient traveller could be torn apart, its billion-year journey ending in a violent, spectacular death. And that raised a haunting question. Would Comet Atlas survive long enough to reveal its secrets? Or would its story end here, within the borders of our solar system? For centuries humans have gazed at the night sky and wondered what might be passing through it unseen. Every so often, a streak of light or the hazy glow of a comet would appear, and civilizations would weave stories of omens, gods, or impending change. But in modern astronomy, with all of our telescopes and data-driven tools, we've become accustomed to thinking we know our neighbourhood. We track thousands of asteroids, hundreds of comets, even small specks of debris drifting around the sun. So when a completely alien visitor arrives, something not bound to our star at all, it forces us to stop and question how much we truly understand. That is exactly what happened in 2009, when astronomers caught sight of something unusual moving through the darkness. At first, it didn't look like much, another faint icy body catalogued and logged like so many before it. But within days it became clear, this was not just another local comet. This was a traveller from the stars. The object was first noticed by a robotic telescope survey designed to scan the heavens for anything new, unusual, or potentially dangerous. Such surveys churn out countless detections, most of which are routine. But this one was different. It wasn't just the brightness or the faint smudge of a tail beginning to form, it was its motion. Astronomers quickly realized it was moving too fast on too steep a trajectory to be just another comet looping around the sun. Its orbit wasn't closed, it was open, hyperbolic, meaning it would come in once, swing past, and leave forever. Unlike the familiar elliptical orbits of planets, moons, and comets that belong to our solar system, this object was clearly unbound. It had arrived from interstellar space, and after a brief encounter with our sun, it would vanish back into the void. That fact alone made it historic. Only two other confirmed interstellar objects had ever been spotted before this. The famous Oumuamua in 2017, which caused endless speculation about its cigar-like shape and possible artificial origins, and Comet Borisov in 2019, which looked more like a traditional comet but still carried unmistakable signs of an alien birthplace. For astronomers, catching one of these wanderers is like winning the lottery. They are rare, fleeting, and incredibly valuable. To suddenly have another one appear so soon after the others was shocking. And this one was stranger still. The comet quickly received an official name, C2019 Q4, though most came to know it simply as Comet Atlas. The excitement around its discovery spread rapidly through the scientific community. Here was an object that had likely formed around a different star system billions of years ago, ejected during the chaotic early days of planetary formation, and left to drift through interstellar space ever since. Imagine a tiny frozen shard of another world's history, casually passing by our doorstep. It was the closest thing to holding a piece of an alien planet in our hands, except this shard was moving at incredible speed, on a trajectory that would make it nearly impossible to study up close. What made Atlas stand out right away was not just its orbit, but its appearance. Early observations revealed it wasn't behaving like an ordinary comet. Its brightness was unusual, its chemical makeup didn't match the patterns astronomers were used to, and even its outgassing seemed asymmetric, as though it were venting material in odd directions. These strange traits suggested it wasn't just an average icy rock, but a relic with a complex history, shaped by conditions we had never witnessed before. The more scientists looked at it, the clearer it became. This was a one-of-a-kind opportunity. But the story of Atlas's discovery wasn't just about science, it was also about awe. For the public, news spread quickly that we were being visited by something alien, something not native to our solar system. The idea that this icy traveller had journeyed for billions of years before finally crossing paths with us captured the imagination of people around the world. Unlike planets or moons that have circled the sun for ages, this was a true outsider, here for a brief encounter and then gone forever. There was a sense of cosmic drama in its arrival, as though the galaxy had handed us a message in a bottle, and we had only a short window to open it before it drifted away again. At observatories across the globe, astronomers rushed to capture as much data as possible. Each night of observation mattered, because the comet was moving quickly, and its brightness fluctuated in ways no one fully understood. Some feared it might fragment or disintegrate before long, robbing us of the chance to study it further. Others hoped it would remain intact long enough to reveal its secrets. Either way, there was no time to waste. Part of the fascination came from the realization that this wasn't just a comet, it was a survivor. To have travelled across interstellar space, through radiation fields, dust clouds, and gravitational encounters, and still remain mostly intact, meant it was incredibly resilient. Every scratch, every scar on its surface carried clues about the environments it had passed through. If we could decode those clues, we could glimpse not only its story, but also the larger story of how planetary systems form and evolve across the galaxy. It was like studying a fossil that didn't belong to Earth at all, a relic from a world light years away. But discovery is only the beginning of any good story, and Atlas's path was far from safe. Even in the first days after it was spotted, calculations revealed something unnerving. The comet's trajectory would take it straight through the asteroid belt, a region teeming with rocky debris. For an object already fragile and unpredictable, this was a perilous crossing. The comet wasn't just drifting quietly by. It was heading toward a cosmic gauntlet, one that could easily shatter it into pieces before it ever left our solar system again. The thought of losing such a rare interstellar treasure so quickly added an edge of tension to every new observation. Would we get to see this alien visitor reveal itself, or would its story end in silence, buried among the rocks of the asteroid belt? What made the discovery of Atlas so powerful was the combination of wonder and danger it embodied. On one hand, it was a gift, a chance to study something utterly foreign, to glimpse chemistry and physics shaped around another star. On the other, it was a ticking clock, a fragile body racing toward hazards that could end its journey at any moment. It wasn't just a comet anymore, it was a cosmic cliffhanger unfolding in real time, and so, as astronomers traced its arc across the sky, the world watched. Every new image, every data point carried with it the thrill of discovery and the dread of loss. Comet Atlas was no longer just a faint smudge of light in the darkness. It was a symbol of how vast and mysterious the universe truly is, a reminder that our solar system is not an isolated bubble, but a crossroads, where ancient travellers from distant stars can sometimes wander in. And with that realization came the burning question that would drive the months ahead. What secrets would this interstellar visitor reveal before it vanished forever? The first sign that Comet Atlas was no ordinary wanderer lay in the mathematics of its path. When astronomers chart the orbit of a comet, they usually expect to find the familiar shapes of closed ellipses, the same stretched circles that keep planets locked to the sun and moons bound to their planets. A comet born in the Oort cloud, that icy shell surrounding our solar system, will still obey this rule. Even if its orbit takes thousands or even millions of years to complete, it eventually returns. Atlas, however, refused to follow such a pattern. Its trajectory was not curved in a gentle loop but flung open, a hyperbolic escape route. It was the celestial equivalent of a stranger walking into a room, refusing to sit down, and heading straight out the opposite door without pause. The mathematics made it undeniable. This object was not native to our sun's family. It had come from somewhere else entirely. To prove an object's interstellar origin, astronomers look first at something called eccentricity, a number that describes how stretched an orbit is. For an object in a perfect circle, the eccentricity is 0. For the planets, which move in slightly squashed circles, it is small but close to 0. For the icy comets that dive in from the outer reaches of the Oort cloud, eccentricity often hovers close to 1, meaning their orbits are extremely stretched but still technically closed loops. But when eccentricity rises above 1, you're no longer talking about an orbit at all. You're talking about a flyby, a path that comes in, swings around, and exits forever. Atlas's eccentricity wasn't just slightly above 1, it was dramatically so, leaving no doubt that it was interstellar. Then there was the matter of speed. To escape the sun's gravitational pull entirely, an object has to move at what's known as escape velocity. Near Earth's orbit, that number is around 42 kilometers per second. Atlas wasn't just moving that fast, it was exceeding it. Long before it even reached the inner solar system, its velocity had already made clear that no amount of solar tug could capture it. It was simply passing through, as though the sun were just another landmark along an endless road. Astronomers calculated that Atlas was barreling in at tens of kilometers per second, faster than anything we'd expect from a local comet. It wasn't being flung outward by a gravitational assist. It wasn't the fragment of a known family. It was a true outsider, one whose energy could only have been imparted by an entirely different star system's birth pangs. These numbers alone, its hyperbolic orbit, its eccentricity far above 1, its speed exceeding escape velocity, were enough to convince scientists. But the deeper proof came from comparisons to other bodies we've seen. Every local comet carries certain chemical fingerprints and orbital behaviours shaped by the environment in which it formed. They are children of the same nursery, sharing a set of common traits. Atlas, on the other hand, looked like it had been raised under completely different conditions. Its chemistry leaned heavily toward carbon dioxide, far more than the water, ice and dust ratios we're accustomed to. The balance of frozen gases venting from its surface didn't fit any of the categories neatly filed away in our comet catalogues. In a sense, it was as if we had met a distant cousin who carried the unmistakable DNA of family, icy tails, venting jets, but whose accent and appearance told us instantly that they came from a place we had never visited. Astronomers love hard evidence, but in the case of interstellar visitors, much of the evidence is circumstantial. You can't fly out to another star system and confirm where an object was born. Instead, you rely on the weight of probabilities, on the paths that make no sense unless the body originated beyond the sun's influence. And in that weight of probabilities, Atlas was conclusive. Statistically, the odds that a comet with such a trajectory could have been ejected from our own system and returned in such a pattern were vanishingly small. The math simply didn't allow it. It had to have been cast out of some other planetary nursery long ago, perhaps during the chaotic collisions of giant planets in the early days of its home system. Its presence here was not random. It was the direct consequence of billions of years of galactic wandering. To the public, all of this could be simplified into a single breathtaking statement. This comet was not from here. That sentence carried weight far beyond astronomy. To say that something visible in our sky had begun, its life circling another star, was almost spiritual in its implications. It was a reminder that the universe is not divided into neat compartments. Material travels, drifts, migrates. What is alien today may someday become local. And for once, humanity had caught the process in motion. The orbit also hinted at just how ancient Atlas was. Its hyperbolic trajectory suggested it had been moving freely through the galaxy for an almost unimaginable span of time. Objects like this don't simply appear. They are ejected during violent moments in the youth of planetary systems, when giant planets shift positions and sling smaller bodies outward like pebbles from a slingshot. If Atlas had been wandering ever since, it could have spent billions of years crossing between stars, perhaps longer than life has existed on Earth. Its very presence was like a living fossil, carrying within it the record of a time long before our solar system formed. And then came the comparisons. The astronomy community could not resist placing Atlas alongside the two other known interstellar visitors, Oumuamua and Borisov. Oumuamua had stunned the world with its bizarre elongated shape, its sudden acceleration that some suggested might be artificial, and its complete refusal to look like any known comet or asteroid. Borisov, discovered shortly after, seemed more conventional, a comet whose behaviour matched expectations even if its chemistry pointed to alien origins. But Atlas was something different again. It was larger, brighter, and less predictable. It showed unusual chemical balances, and its path took it straight through regions of the solar system we understood intimately, giving us a chance to see how an alien body interacted with familiar territory. If Oumuamua was the strange and mysterious messenger, and Borisov the reassuringly comet-like cousin, Atlas was the wild card, an unpredictable guest whose behaviour couldn't be neatly filed under any category. For scientists, the proof of interstellar origin wasn't just a label to slap on a catalogue entry. It was a key that unlocked permission to ask deeper questions. If this object was truly alien, then every piece of data about it mattered enormously. Its speed, its rotation, its chemistry, even the way its tail bent in the solar wind, all of it became precious clues about what conditions are like in other parts of the galaxy. And perhaps most tantalizing of all, the comet wasn't just visiting, it was plunging straight into one of the most dangerous regions of our own system, the asteroid belt. That meant we had the chance to witness something entirely new, how a body forged around another star would behave when thrown into the most chaotic region of ours. In the end, the proof was overwhelming. By every measure, its orbit, its eccentricity, its speed, its chemistry, Comet Atlas had to be interstellar. It was not one of us. And in that realization came a thrill that shook even the most sober scientists. To prove something is alien is to admit that the universe is larger and more interconnected than we usually allow ourselves to feel. It meant that material was constantly moving between stars, that the building blocks of worlds were not confined to neat borders. Atlas was evidence that our solar system is not a closed system, but a crossroads, one of many along the galactic highways. And yet, with proof came unease. Because if Atlas was truly from beyond, then its survival mattered even more. Every second it remained intact was a second we could study and learn from it. Every second it risked destruction was a chance slipping away forever. The proof of its interstellar origin made it precious, but also fragile. The universe had handed us a rare gift. The question now was whether we could hold on to it long enough to uncover its story before it shattered into pieces, lost to the void once more. When scientists turned their instruments toward Comet Atlas, they weren't just interested in where it came from. They wanted to know what it was made of. Chemistry is the fingerprint of a comet, the story it carries frozen inside its ices and dust. By examining the gases released as sunlight warms its surface, astronomers can piece together a picture of the environment in which it formed. For the comets native to our solar system, those fingerprints have become familiar over decades of study. Water ice is the dominant player, accompanied by carbon monoxide, methane and other volatile compounds, with the occasional surprise but always within a range we have come to expect. Atlas, however, broke that mould immediately. As the sun's light began to stir its frozen layers, instruments detected an unusually strong release of carbon dioxide. This was not unheard of in comets, but the scale of it, the dominance of CO2 over water, was startling. For local comets, water ice is usually the driver of activity as they approach the inner solar system, vaporizing to form tails and jets. Atlas seemed to be powered by something else entirely, its life force tied more strongly to carbon dioxide than to water. To many astronomers, this was a red flag that the comet had formed under conditions very different from those of the solar system's outer regions. It was as though the recipe for Atlas had been written in a different kitchen altogether, one where the balance of ingredients was skewed toward gases less common in our cosmic backyard. The implications were profound. If Atlas carried more carbon dioxide than typical, it suggested the disk of material from which it was born must have been colder, with different temperature gradients than the one that gave rise to our own planets and comets. In the solar system, CO2 ice can exist, but it sublimates easily if conditions are not frigid enough. For Atlas to have so much, its nursery must have been a place where carbon dioxide could accumulate abundantly, locking itself into the body of the comet without being stripped away. This raised questions about the star system it once belonged to. Was it a smaller, dimmer star, where the icy line extended closer in? Or perhaps a star born in a dense cluster, where radiation from neighbouring suns created unusual chemistry in the disk? But Atlas didn't stop with its carbon dioxide surprise. Other measurements hinted at volatile ratios that didn't match the trends in our catalogues. Some astronomers speculated that its unusual chemistry could point to a planetary system older than ours, shaped during an era when the galaxy itself was chemically younger and less enriched by heavy elements. In that sense, Atlas might be a time capsule, preserving conditions that predated the Sun. Its dust grains, its frozen layers, even its trapped gases might be older than Earth itself, carrying whispers of environments long vanished from the galaxy. To study Atlas was to peer into an ancient chapter of cosmic history, one that we could not access in any other way. For the scientists who dedicate their careers to cometary chemistry, every molecule escaping from Atlas was like a word in a long-lost language. Water vapour, carbon monoxide, methane, ammonia, all could be measured, compared, analysed. The balance between them could be translated into environmental conditions. And what emerged was a picture that didn't quite fit any template we knew. It was close enough to resemble a comet. After all, it had a coma, a tail, jets of gas. But it was alien enough to make us pause. It was the cousin who looked like family, but whose habits and stories revealed a life lived elsewhere, under different skies. This alien fingerprint carried with it a new wave of speculation. If comets from other systems could have such different compositions, what might that mean for the diversity of planets orbiting distant stars? After all, comets are the leftovers, the building blocks that didn't quite make it into full planets. If Atlas carried a different balance of ices, then the planets in its home system must have formed from a different soup of ingredients too. The presence of carbon dioxide in such abundance could suggest planets rich in exotic ices, atmospheres heavy with CO2, or environments far colder than Earth. In other words, Atlas was not just teaching us about itself, it was teaching us about alien worlds we would never see directly. And yet, amid the scientific awe, there was a tension. Atlas was fragile. Comets are not solid rocks. They are loosely bound piles of ice and dust, often described as dirty snowballs. When one begins to warm, pressure builds beneath its crust, leading to eruptions of gas and dust. If the structure cannot withstand the stress, the comet can fragment, sometimes spectacularly, into smaller pieces that fade away. The unusual chemistry of Atlas hinted that its internal structure might also be unusual. If it had more carbon dioxide than water, then it might vent differently, more explosively, unpredictably. Already, telescopes were observing outbursts that seemed oddly asymmetric, as though jets were blasting from hidden vents, rather than spreading evenly. This suggested weaknesses within its body, fractures waiting to widen. Every new observation added to the suspense. Would this alien comet hold together, or was it destined to tear itself apart before we learned its full story? For the broader public, the phrase alien chemistry carried a mystique of its own. News outlets seized on the idea that this comet wasn't just another icy rock but something fundamentally different. To say it carried the recipe of another star system made it sound almost alive, a messenger bearing secrets across the void. And in a sense, that wasn't far from the truth. Atlas had preserved in its frozen core a set of conditions we could never replicate on Earth. Its ices had been shielded from sunlight for billions of years, travelling silently through interstellar space. Now, in the glare of our sun, it was finally speaking, releasing its hidden story into the light. The question was whether we could listen quickly enough before it disintegrated into silence. The excitement reached beyond pure science into the realm of imagination. Some wondered whether comets like Atlas could carry not only exotic chemistry, but also the seeds of life. If the building blocks of life can exist in frozen bodies, and if those bodies wander between stars, then perhaps the galaxy itself is stitched together by a network of comets, trading material from system to system. Atlas, with its unusual chemistry, became a symbol of that possibility. Could it be that life's origins are not confined to one star system, but are a galactic phenomenon passed along by ancient travellers like this one. The speculation was irresistible, even if the hard evidence remained elusive. Still, what anchored the story of Atlas was the data. Molecules venting into space, measured by telescopes tuned to the infrared and ultraviolet, built a picture of a comet unlike any we had seen. Alien not in the sense of science fiction, but alien in the sense of not from here. Each measurement confirmed that Atlas was not simply a copy of local comets with a strange orbit. It was fundamentally different, its chemistry shaped by another star's nursery. That realization alone made it one of the most valuable visitors we'd ever encountered. But the chemistry also hinted at danger. A body dominated by volatile gases like carbon dioxide could be more fragile, more prone to violent outbursts as the sun's heat dug deeper into its crust. Astronomers knew the odds. Many comets fall apart under such stress, leaving behind only debris clouds. If Atlas followed that fate, we would lose our chance to study its full story. The very chemistry that made it so fascinating could also be its undoing. The irony was brutal. The secrets of another star system were locked in its fragile ices, and those ices were melting away faster than we could capture their message. In the end, the chemistry of Comet Atlas was both its greatest gift and its greatest curse. It revealed without doubt that this was a traveller from beyond carrying the fingerprints of a foreign birthplace. It offered us a window into planetary nurseries we might never otherwise glimpse, and yet the very act of revealing that chemistry was destroying the comet itself, peeling away its surface, cracking its core, and pushing it closer to disintegration. For scientists, this was both exhilarating and heartbreaking. Atlas was speaking to us, but its voice was the sound of its own unravelling. When astronomers pieced together the trajectory of Comet Atlas, the numbers told them more than just where it was going. They whispered of where it had come from and how long it had been travelling. Every orbit, every speed, every tilt of its path is like a breadcrumb leading back into the past. And in Atlas's case, those breadcrumbs pointed not to a recent ejection or a nearby star, but to something staggeringly ancient. The calculations suggested that Atlas had not merely wandered through space for a few million years, but potentially billions, crossing the galaxy again and again before finally intersecting with the solar system. In other words, this wasn't just an interstellar visitor, it was an interstellar survivor. The key lies in the galactic structures astronomers know as the thin disk and the thick disk. Most of the stars we see in the night sky belong to the thin disk of the Milky Way, a relatively young, orderly structure where stars like the Sun orbit calmly around the galaxy's centre. The thick disk, however, is older, rougher, populated by stars born in the galaxy's early days. Objects associated with the thick disk often have orbits tilted steeply against the galactic plane, cutting through the galaxy at odd angles, their paths shaped by ancient upheavals. When astronomers modelled Atlas's trajectory, they found hints that it may belong to this older population. That meant Atlas could be older than Earth itself, forged before our planet even existed, ejected during the violent youth of its home system, and left to drift through the Milky Way ever since. To think about what that really means, imagine the timeline. Our solar system formed about 4.6 billion years ago. Before that, the galaxy was already busy creating and destroying stars, forging planets around them, scattering comets and asteroids into interstellar exile. If Atlas belonged to one of those earlier systems, it might have been cast out while the Earth was still just a cloud of dust and gas. While our world was forming, oceans were rising, and life was beginning its long climb from microbes to complex beings, Atlas was already adrift, orbiting the centre of the Milky Way in vast, slow arcs. It has been circling the galaxy for longer than humanity can truly comprehend, surviving radiation storms, gravitational jolts, and collisions with dust clouds, yet somehow remaining intact enough to arrive here today. What does a body experience over billions of years in deep space? Unlike the inner solar system, where sunlight and planetary encounters constantly reshape comets, interstellar space is a cold, quiet desert. Temperatures hover near absolute zero, and sunlight is but a faint glimmer from faraway stars. For most of its life, Atlas would have been frozen solid, dormant, a block of ice and dust locked in stasis, its chemistry preserved like a fossil, unchanged since the moment of its birth. But that doesn't mean its journey was easy. Passing through the galaxy exposes a traveller to cosmic rays, high-energy particles that can chip away at molecules, altering their surfaces in ways we can detect billions of years later. Astronomers who look at Atlas's chemistry see not just the fingerprint of its birth, but also the scars of its long trek. Its crust is a palimpsest, marked by both origin and endurance. The very fact that Atlas survived this journey is remarkable. Comets are fragile things, often described as loose piles of rubble, barely held together by their own gravity. Many don't even survive a single close pass around the Sun without breaking apart. For Atlas to have endured not just one journey, but billions of years of drifting means it was either incredibly lucky or forged in a way that gave it unusual resilience. Perhaps its internal structure was compact enough to resist slow erosion. Perhaps its chemistry helped it resist fracturing in deep freeze. Whatever the reason, when it entered our solar system, it carried with it the weight of untold history. It was as if a messenger had walked into our world carrying a scroll written not yesterday or last century, but before human civilization, before Earth itself, sealed tightly against the ravages of time. Astronomers couldn't help but speculate on the kind of system Atlas had been born in. Was it a binary star, where the push and pull of two suns could sling icy bodies into the void? Was it a young star with giant planets migrating inward and outward, scattering comets like billiard balls? Or was it something more exotic, perhaps even a star that no longer exists, its nursery obliterated by time? If that were true, Atlas would be more than an interstellar traveller. It would be a relic of a dead system, a fragment of a world erased from existence, preserved only in this drifting shard of ice. The idea that we might be looking at the last surviving piece of a vanished solar system was both thrilling and sobering. The galaxy itself has changed dramatically during the time Atlas has been wandering. Stars have been born and died in spectacular supernovae, seeding space with heavy elements. Spiral arms have rotated, clusters have formed and dissolved. Our solar system has completed nearly 20 full orbits around the galaxy's centre in the span of 4.6 billion years. Through all of that, Atlas has been quietly circling, a tiny frozen witness to the grand theatre of galactic evolution. To hold such an object in our telescopes, even briefly, is to touch a timeline that dwarfs human history. And this sense of deep time added to the comet's aura of mystery. Because if Atlas was truly this old, then every molecule it carried was a clue to conditions that existed before Earth's story began. Its chemistry was a direct sample of a galactic environment that no longer exists. Just as paleontologists study fossils to reconstruct ecosystems from millions of years ago, astronomers could study Atlas to reconstruct planetary nurseries from billions of years ago. It was a living fossil, except its life was measured not in years but in galactic revolutions. For the public, this idea was mesmerizing. The notion that we could look at a comet in the sky and know it had been travelling since before humans existed, before Earth itself existed, made the encounter almost spiritual. It was as though we were catching a glimpse of eternity, a frozen shard of the galaxy's ancient memory passing briefly within reach. And yet, this same realization also underscored the tragedy of its fragility. To survive billions of years only to risk destruction now, in the crowded asteroid belt, felt almost cruel. The comet's story carried the weight of cosmic irony. It had endured unimaginable distances and epochs, only to face its greatest test in our backyard. Astronomers felt the urgency. With each observation, they were not just studying a comet, they were racing against time, trying to gather as much as possible before Atlas either disintegrated or vanished into the dark once more. Every spectrum, every image, was another page in a book that could close at any moment. And woven through all of it was the knowledge that Atlas wasn't simply a comet from another star. It was a survivor from another era, older than Earth, older than us, carrying a message written at the dawn of galactic history. When Comet Atlas's path was first mapped out, the mathematics painted an ominous picture. This ancient wanderer, forged in the nursery of a long-forgotten star system, was heading directly toward one of the solar system's most notorious regions, the asteroid belt. For centuries, the asteroid belt has been imagined as a dense minefield of rocks, a chaotic graveyard between Mars and Jupiter, where shattered worlds and drifting boulders circle endlessly, Popular culture exaggerates it into a turbulent gauntlet. But even stripped of Hollywood's dramatization, the asteroid belt is no safe passage. It is a region where collisions happen, where fragments race at deadly speeds, and where the wrong trajectory can end a fragile comet's life in a single instant. And Comet Atlas wasn't just brushing past, it was plunging straight through, against the flow of traffic. The danger lay not simply in the presence of rocks, but in Atlas's retrograde motion. Most objects in the solar system orbit the Sun in the same direction, like cars circling a racetrack. The asteroid belt, despite its emptiness compared to movie depictions, still contains millions of bodies moving along predictable lanes. A comet entering on a prograde orbit, moving with the flow, faces reduced risk because its velocity relative to surrounding bodies is lower. But Atlas was different. It was moving retrograde, against the grain, like a driver tearing down a highway in the wrong direction. Even small asteroids, harmless in most circumstances, could become catastrophic obstacles if struck head-on at closing speeds of tens of kilometers per second. For a comet as fragile as Atlas, even a collision with a pebble-sized fragment could trigger devastating fractures. Astronomers began to calculate the odds. The asteroid belt is vast, Yuri, and the spaces between objects are immense. The chance of a direct hit with a large asteroid was statistically tiny. But Atlas didn't need to collide with something massive to be destroyed. The greater danger was the invisible swarm of dust and gravel-sized debris, pieces shed over billions of years by asteroid collisions. These fragments can be as small as grains of sand, yet at interstellar speeds, they are as destructive as bullets. A barrage of micrometeoroids could erode a comet's fragile crust, destabilize its structure, or ignite sudden outbursts of gas. In some ways, the asteroid belt was less a wall of stone and more a cosmic sandblaster. And Atlas was flying directly into the stream. For the public, the image of Atlas threading through the belt sparked a wave of imagination. Headlines compared it to a game of cosmic Russian roulette, a billion-year traveller facing its final challenge. People envisioned colossal explosions, showers of debris and cinematic collisions. In truth, the reality was subtler but no less dangerous. The asteroid belt is treacherous precisely because it is unpredictable. A comet's surface vents gas unpredictably as it heats, creating tiny thrusts that alter its trajectory. Even a slight nudge can shift its path by thousands of kilometers over time, changing where and how it encounters debris. In Atlas's case, its unusual chemistry made these jets even harder to predict. Scientists worried that a sudden asymmetric outburst might nudge it into a denser region of the belt, raising the chances of a catastrophic encounter. Yet there was more at stake than survival. The belt offered an unparalleled opportunity. If Atlas endured the crossing, it would provide astronomers with front-row seats to see how an alien comet interacted with a familiar environment. How would its chemistry respond to the heat and dust? Would its fragile crust shed layers, exposing deeper material? Would it fragment under the stress of solar heating and gravitational tides? Every possibility carried with it the chance to learn something unprecedented. The asteroid belt was both danger and laboratory, a test that could either destroy the comet or reveal its hidden heart. Astronomers remembered past comets that had attempted similar journeys. Many had broken apart under far less stress. Comet shoemaker Levy 9 famously shattered into pieces before slamming into Jupiter, its fragments creating fireballs larger than Earth. Comet Elenin disintegrated as it neared the Sun, leaving behind only a faint smear of dust. Even local comets with sturdy structures often fail when subjected to the combined forces of radiation, gravity, and impacts. For Atlas, already unusual and fragile, the odds seemed stacked against survival. The narrative that began to form was not just scientific but dramatic. Could this relic from another star survive the solar system's most dangerous trial, or was it destined to meet its end here, undone not by billions of years of interstellar wandering, but by the hazards of our own backyard? As telescopes tracked its approach, astronomers watched closely for signs of stress. Every flare in brightness, every twist in its tail, every sudden jet was scrutinized. Was the comet holding together? Was it shedding fragments? The answers were never entirely clear. Comets are unpredictable by nature, and Atlas was even more so. Some nights it seemed to brighten with renewed vigor, releasing spectacular plumes of gas. Other times it dimmed unexpectedly, raising fears that it was fragmenting. Each observation felt like a heartbeat in a tense drama, the comet's fate hanging in the balance. But beneath the tension, there was also awe. The thought that we were watching, in real time, a comet from another star system navigating the asteroid belt was astonishing. It was like watching a stranger from a distant land attempt to cross a treacherous mountain, pass in our own territory. Every wobble, every flare of activity was a reminder that this visitor was truly foreign, carrying with it the scars of another world yet vulnerable to the perils of ours. Scientists and lay people alike found themselves invested in the outcome, rooting for the comet as though it were a living being struggling against impossible odds. The metaphor of a driver against traffic wasn't lost on anyone. Atlas wasn't just threading a cosmic needle. It was doing so while hurtling against the flow, its retrograde path turning every potential encounter into a deadly head-on collision. That alone magnified the risk far beyond the usual. Astronomers calculated that while the chances of a direct asteroid strike were still low, the potential energy of such a collision would be catastrophic. At those relative speeds, even a modest rock could reduce the comet to rubble. The irony was cruel. The very orbit that had carried it safely across interstellar space now brought it face to face with the greatest danger it had ever faced. For the scientists documenting its journey, the asteroid belt crossing was less about whether Atlas would survive and more about what we could learn from watching. If it shattered, the fragments could provide invaluable clues about its internal structure and composition. If it survived, it would offer a rare chance to study interstellar material in unprecedented detail for months to come. Either outcome promised knowledge. But for those who had become emotionally invested, who saw Atlas as a survivor of unimaginable odds, the idea of its destruction was heartbreaking. To have come so far, only to be undone so close to our gaze, felt almost tragic. And so, as Comet Atlas hurtled toward the belt, the world held its breath. It wasn't just a scientific observation anymore, it was a story. A relic older than Earth itself was facing its greatest test, threading through a region littered with hazards, defying the odds as it plunged headlong against the flow. Would it emerge battered but whole, ready to reveal its secrets, or would it break apart, scattering its ancient story into dust before we ever fully understood it? That was the question that turned every observation into a cliffhanger, every calculation into a prophecy, every glimpse into a reminder of how fragile and how extraordinary this interstellar traveller truly was. The first sign that Comet Atlas was truly alive came when the warmth of the sun began to touch its frozen surface. For billions of years, Atlas had drifted in silence through the interstellar dark, its volatile ices locked away beneath a crust that had never known direct heat. Now, for the first time in countless ages, that stillness was broken. Sunlight seeped into its body, sublimating the gases trapped within, and suddenly Atlas was no longer a silent wanderer. It was a roaring, venting comet, announcing its presence with a luminous tail stretching across space. To the eye, it was beautiful. A cosmic brushstroke painted against the black canvas of the void. To scientists, it was something far more important, a revelation of the comet's inner chemistry and a test of its fragile structure. At first, the activity seemed normal enough. Most comets grow a coma, a hazy atmosphere of gas and dust as they approach the sun, and a tail forms as solar radiation pushes that material away. But Atlas was not like most comets. Its tail did not grow symmetrically, nor did its jets follow neat patterns. Observations revealed strange asymmetries, plumes blasting from one side while others sputtered weakly, as though the comet were venting through hidden cracks instead of smooth, predictable vents. This uneven release of gas was like a heartbeat gone irregular, evidence that deep inside Atlas was unstable. It was shedding its secrets in fits and bursts, an ancient body struggling to adapt to a heat it had not felt in eons. What startled astronomers most was how rapidly the comet brightened. Within weeks of warming, Atlas surged in brightness, far outshining predictions, almost as if it were trying to make itself visible before it was too late. Amateur skywatchers reported that it seemed to swell in size night after night, its tail stretching farther, its coma glowing brighter. Some hoped it might become a spectacular naked-eye comet, one of those rare celestial shows that inspire entire generations. But to seasoned cometary scientists, such rapid brightening was not necessarily a good sign. Often it meant a comet was not stable but fracturing, shedding more material than it could sustain. In essence, Atlas might not have been flourishing, it might have been unravelling before our eyes. The chemistry of the outgassing confirmed this suspicion. Instead of being dominated by water vapour, as is the case with most comets near the Sun, Atlas was releasing huge amounts of carbon dioxide, along with dust that glittered in the solar wind. Carbon dioxide sublimates at lower temperatures than water, meaning Atlas was venting vigorously even at a distance where local comets remained quiet. This suggested its crust was riddled with pockets of volatile gases, and once sunlight reached them, the gas exploded outward, carrying dust with it. Each eruption was like a crack in the armour, weakening the comet's structure further. Every jet of gas was both a message from its ancient past and a warning about its uncertain future. Astronomers noted something else. The comet's tail was behaving strangely in the solar wind. Instead of forming a neat, graceful arc like many comets, Atlas's tail seemed prone to disconnection events, sudden breaks where part of the tail snapped away and drifted off into space. These tail disconnections hinted at violent interactions with the solar magnetic field, turbulence in the plasma streams, and instability within the comet's own venting system. For plasma physicists, it was a gift, a chance to study solar wind interactions in a way no spacecraft could replicate. For comet scientists, it was yet another sign of Atlas's fragility. If the tail was unstable, the body producing it might not hold together for long. For the public, however, the awakening of Atlas was a moment of awe. Images circulated showing its shimmering tail stretching millions of kilometres, its greenish coma glowing with the light of ionized gases. People began to imagine that they might see it without telescopes, a celestial visitor gracing the sky as ancient comets had done for millennia. Social media buzzed with anticipation, talk of a great comet filling news feeds. The story of its alien origins only added to the mystique. This wasn't just another comet, it was a messenger from the stars, and now it was writing its message across our heavens. But behind the beauty lurked unease. Those who had studied comets for decades recognized the signs of potential catastrophe. A tail that brightened too quickly, a coma that swelled unnaturally, a symmetric outgassing. These were all hallmarks of comets nearing collapse. Astronomers remembered Comet Ison, once heralded as the comet of the century, which disintegrated spectacularly as it neared the Sun, leaving behind only a ghostly wisp of dust. Would Atlas follow the same fate? The parallels were unsettling. Both had been hailed as great comets, both had shown rapid brightening, both had hinted at fragility. For Atlas, the asteroid belt loomed ahead, amplifying the risk. The combination of internal instability and external hazards painted a grim picture, and yet there was something almost poetic about its awakening. For billions of years, Atlas had travelled unseen, silent, dormant. Now, in its final act, it was blazing with light, revealing itself to anyone willing to look up. It was like a traveller who had remained cloaked in shadows for ages, suddenly stepping into the spotlight, unveiling their face before vanishing again. Whether it survived or shattered, the comet had already given us something priceless, a glimpse into the chemistry of another star system, a cosmic relic briefly laid bare. Its tail was not just a plume of dust and gas, it was the comet's voice, speaking across the gulf of time, telling us where it had come from and what it had endured. The emotional weight of this awakening was not lost on astronomers. Each night of observation became more urgent, more precious. Every photon of light captured by telescopes was another clue, another piece of the puzzle. They knew that time was against them. The sun would only grow stronger, the pressures inside Atlas more unstable, the risks greater with each passing day. Whether the comet emerged from the asteroid belt intact or disintegrated in a burst of dust, the countdown had begun. The awakening of Atlas was both a beginning and an ending, a reminder that beauty and fragility often walk hand in hand in the cosmos. And so the world watched. The tail stretched, the coma brightened, the comet roared with activity, and the question loomed larger with each observation. Was this the triumphant awakening of a survivor, or the final flare of a body on the verge of destruction? Atlas was awake, alive, dazzling, and yet, like a candle burning too brightly, its flame hinted at its own impermanence. The next chapters of its journey would determine whether its story continued or ended in silence. Scattered as dust among the planets, it would never call home. Comet Atlas may have been extraordinary, but it was not the first interstellar visitor to pass through our solar system. To truly understand why Atlas generated so much excitement and tension, we need to look back at the others that came before it, the cosmic wanderers that shattered our sense of isolation and reminded us that our sun is just one stop along the endless highways of the galaxy. Each interstellar visitor told a different story, and each one rewrote the way we think about the universe. Compared to them, Atlas seemed both familiar and utterly alien, carrying echoes of their mysteries while presenting new questions of its own. The first of these visitors to be confirmed was Oumuamua, discovered in 2017. The moment astronomers plotted its trajectory, they realized it was not bound to the Sun. It was interstellar. But Oumuamua refused to behave like anything we had ever seen before. Unlike a comet, it had no visible tail, no coma of dust and gas to betray venting ices. Instead, it was a dark, elongated object, tumbling strangely as it passed through the inner solar system. Estimates of its shape suggested it was either cigar-like or perhaps pancake-shaped, but either way, it was unlike any asteroid or comet catalogued before. Even more puzzling was its acceleration. As it left the inner solar system, Oumuamua sped up in a way that could not be fully explained by gravity alone. Some scientists argued that outgassing might have been responsible, invisible jets pushing it along, while others suggested exotic explanations, including the possibility that it was artificial, a fragment of alien technology, or a solar sail designed by another civilization. While most astronomers dismissed the wilder claims, the debates highlighted just how little we knew about the objects drifting between stars. Oumuamua was a riddle without a clear answer, and it left behind more questions than it solved. Then came Borisov in 2019, the second confirmed interstellar visitor. Unlike Oumuamua, Borisov looked and acted much more like a traditional comet. It had a coma, a tail, and vented gases in ways that matched expectations, but its chemistry betrayed its alien origins. Borisov carried unusual ratios of carbon monoxide and water, different from local comets, confirming it was forged in a different planetary nursery. In some ways, Borisov reassured astronomers, it proved that interstellar visitors could look like the comets we were familiar with, only subtly different in their compositions. It was a reminder that while the galaxy is diverse, there are still patterns that echo across star systems. Borisov was strange, yes, but it was also comfortingly recognizable, a cousin from afar rather than a complete stranger. Into this context arrived Atlas. Where Oumuamua had been silent and enigmatic, Atlas was noisy and flamboyant. Where Borisov had been steady and comet-like, Atlas was unpredictable and unstable. In a sense, Atlas combined elements of both. Like Borisov, it vented gases and displayed a vivid tail, making it clearly a comet. But like Oumuamua, it defied easy explanation with its unusual chemistry, its dramatic brightening, and its unstable outbursts. It was as though the galaxy had delivered us a trilogy of interstellar visitors, each one stranger than the last, each one pushing us to expand our understanding of what normal means. The comparisons fascinated astronomers. With only 3 interstellar visitors on record, each one carried outsized importance. Oumuamua hinted that rocky or elongated bodies could wander between stars, Borisov confirmed icy comets did the same, and Atlas demonstrated that the diversity might be even broader than we imagined. Together they told us that our solar system is not isolated, that we are constantly intersecting with the debris of other worlds. Somewhere out there, countless other objects like them are drifting silently through the galaxy, most of them unseen, a hidden traffic of alien material threading through the stars. The fact that we had detected 3 in such a short span suggested there might be far more of them than we had previously guessed. The galaxy, it seemed, is littered with the leftovers of planetary formation, and from time to time, a few of those leftovers wander close enough for us to glimpse. For scientists, Atlas was particularly exciting, because it gave them a chance to compare interstellar comets side by side. Why did Borisov remain relatively stable while Atlas seemed so fragile? Why did Atlas carry such a high concentration of carbon dioxide, when Borisov had leaned more toward carbon monoxide? Why did Oumuamua show no outgassing at all, despite its acceleration? Each comparison sharpened the mysteries rather than resolving them. It was as though the universe was reminding us of its complexity, dangling pieces of a puzzle that could not yet be assembled. For the public, the narrative was just as powerful. Oumuamua had captured imaginations as a possible alien probe, sparking headlines and science fiction scenarios. Borisov had been a quieter story, a comet from another star that looked almost ordinary. Atlas, by contrast, became a story of drama, a fragile alien traveller plunging into danger, blazing brightly as it risked disintegration. Each visitor carried a different emotional resonance, and together they painted a picture of a galaxy that was alive with wandering messengers. Atlas stood out because it felt more personal, more precarious. Its fate seemed tied to our ability to observe it in time, to listen before its voice went silent. Comparisons also carried a humbling message. If we had detected 3 interstellar visitors in just a few years, how many had passed unnoticed before? How many ancient travellers had swept through the solar system in the past, unseen by human eyes, leaving no trace? And how many would pass in the future, carrying with them secrets we might never uncover? Oumuamua, Borisov, and Atlas were not anomalies. They were glimpses of a much larger reality, a constant exchange of material between stars that had been happening long before humans existed and would continue long after we are gone. Atlas's uniqueness was amplified by its timing. Coming so soon after Oumuamua and Borisov, it felt like part of a pattern, as though the galaxy was suddenly opening its gates and letting us peek at its wanderers. Of course, this was only perception. Our technology had simply become better, our surveys more precise, our awareness sharper. But perception matters. For the first time in human history, we weren't just theorizing about interstellar visitors. We were watching them, studying them, and realizing that the galaxy was not a closed set of isolated systems, but a vast interconnected arena where material drifted freely. In this light, Atlas became more than just a comet. It was the next chapter in a growing saga, one that forced us to reconsider the boundaries of our cosmic home. Oumuamua had unsettled us, Borisov had reassured us, and Atlas challenged us once again, showing us that the diversity of interstellar travellers was wider than we had dared to imagine. And unlike the others, Atlas wasn't just passing through quietly. It was heading straight into danger, a cliffhanger unfolding in real time. Its story carried both scientific weight and dramatic suspense, and that combination made it irresistible. So as astronomers studied Atlas, they did so with the ghosts of Oumuamua and Borisov in mind. They compared notes, ran models, debated differences, and speculated about the unseen population of wanderers still out there. The conclusion was inescapable. Interstellar visitors were not rare flukes, but regular actors in the galactic theatre. Atlas was proof that our solar system is a crossroads, not a cul-de-sac, and that our skies are visited by the relics of countless alien worlds. Whether Atlas survived or not, it would remain part of a trilogy that redefined our understanding of cosmic traffic. And in that trilogy, Atlas was the most volatile, the most dangerous, and perhaps the most revealing of all. The solar system is not an empty stage. It is filled with invisible forces, streams of particles, magnetic fields, rivers of energy, that weave together in ways both beautiful and violent. Among the most powerful of these is the solar wind, a constant outpouring of charged particles streaming from the sun at hundreds of kilometers per second. For most of us, it's invisible, an abstraction we might only recognize when it dances across the sky as auroras near the poles. But for Comet Atlas, the solar wind was no abstraction. It was a relentless current, a storm it could not avoid, a force that would shape its very existence as it drew closer to the sun. And in its struggle with this invisible torrent, Atlas transformed into something unexpected, a laboratory, a natural experiment in plasma physics that scientists could never hope to create on Earth. As the comet's ices sublimated and jets of gas poured into space, its coma swelled, a vast atmosphere surrounding the tiny nucleus. This coma, though fragile and tenuous, acted as a shield, colliding with the onrushing solar wind. At the boundary where the comet's gases met the sun's plasma, shock waves formed, bow shocks, much like the waves created at the prow of a ship cutting through water. Here, the delicate molecules venting from Atlas collided with high-energy particles from the sun, breaking apart, ionizing, and creating a chaotic zone of plasma turbulence. Every comet interacts with the solar wind in this way, but Atlas was different. Its unusual chemistry, its erratic outgassing, and its sheer fragility made its interactions uniquely violent. Scientists observed its tail flicker, twist, and even snap, as though invisible hands were tugging at it. Each disconnection was a message. The plasma environment around Atlas was unstable, unpredictable, and profoundly strange. To plasma physicists, this was a treasure. Creating such conditions in a laboratory on Earth is nearly impossible. The scales are too vast, the energy is too high, the particles too tenuous. But in Atlas, nature had created the perfect experiment. By studying the way its tail shifted, broke, and reformed, scientists could infer details about the solar wind itself, its density, its magnetic structure, its turbulence. In effect, Atlas became a probe, a natural spacecraft sent from another star, now revealing not only its own secrets, but also the secrets of the Sun's invisible storm. Telescopes captured images of its tail disconnection events, moments where the plasma pressure overwhelmed the comet's ability to hold on to its ionized gases, severing the luminous stream and letting it drift away like smoke torn from a fire. These events weren't just pretty, they were data, rich with clues about the invisible forces sculpting our solar system. But there was a darker side to this cosmic experiment. Every time the solar wind tore at Atlas, it exposed weaknesses. The comet's nucleus, only a few kilometers across, was fragile to begin with. The asymmetric venting of its unusual ices made it even more vulnerable. Each plasma storm stripped away layers of material, each disconnection event weakened the balance of gases surrounding it. Atlas was not simply surviving the solar wind, it was being battered by it, reshaped, tested to its limits. The more spectacular the displays of plasma turbulence became, the greater the fear that Atlas would not hold together long enough to complete its journey. The very phenomena that made it so scientifically valuable were also signs of its potential doom. Observers around the world marveled at the comet's behavior. Amateur astronomers posted images of its shifting tail, noting sudden kinks and bends that appeared overnight. Professionals used advanced instruments to analyze the changes in detail, tracing magnetic field lines and particle flows through the patterns of light. The comet seemed alive, its tail a living thing writhing in response to unseen blows. Some likened it to a flag in a hurricane, torn and battered but still flying defiantly. Others saw it as a candle in the wind, burning brightly but doomed to be snuffed out by forces too powerful to resist. The comparisons to past comets were inevitable. Many comets have shown tail disconnection events, but Atlas's were unusually frequent and dramatic. Its alien chemistry seemed to enhance the instability, creating conditions rarely seen in local comets. For scientists, this confirmed that Atlas was not just another traveller, it was unique, an opportunity to study plasma interactions under conditions we'd never encountered before. Each event was a window into both the comet's fragility and the ferocity of the solar wind. But for those invested in Atlas's survival, these events carried an ominous weight. Every snapped tail was a reminder that the nucleus itself might not be far behind. If the outer layers were so easily stripped, what chance did the core have against the relentless forces closing in? The asteroid belt was already a looming hazard, but now the sun itself seemed to be conspiring against the comet. It was caught in a crossfire, dust and rocks ahead, plasma storms behind, and within itself, the volatile chemistry of a body never meant to endure such heat. And yet, this struggle was precisely what made Atlas so compelling. It wasn't just a comet. It was a drama unfolding in real time, a story of survival against overwhelming odds. Each night of observation was another episode, each disconnection event another plot twist. Would Atlas hold together? Would it reveal its inner secrets before disintegrating? Or would it shatter suddenly, leaving us only a cloud of dust and a memory of what might have been? The suspense was palpable, not just for astronomers, but for anyone following the story. For the scientific community, Atlas's role as a plasma laboratory carried implications beyond itself. By studying how it interacted with the solar wind, they could refine models of space weather, improve predictions of how plasma storms affect planets and spacecraft, and better understand the universal processes that shape cosmic bodies. In this way, Atlas was more than a fragile traveller. It was a teacher, a natural experiment that might help us protect our own technologies and future explorers. The irony was that this priceless laboratory was also self-destructive. Every lesson it taught came at the cost of its own survival. In the end, the awakening of Atlas's tail was both a spectacle and a warning. It showed us the raw beauty of plasma interactions, the delicate dance between solar wind and alien ice, the luminous trails carved by invisible storms. But it also revealed just how fragile the comet was, how close it stood to collapse. The tail was not just a symbol of life, it was a symbol of struggle, a banner of resistance against forces too vast to overcome. Watching it snap and reform was like watching a heartbeat falter, knowing that the end might come at any moment. And so Atlas became more than just an interstellar visitor. It became a stage on which the invisible forces of the universe played out in vivid, visible form. It became a reminder that the cosmos is not silent but alive with currents and storms. And above all, it became a question. Could a fragile relic from another star endure the plasma storms of the sun, or would it break apart, scattering its ancient secrets into space before we could fully understand them? The answer lay not in the distant past of its birth, nor in the deep future of its destiny, but in the immediate precarious present. One tail flicker, one outburst, one storm away from final silence. While the asteroid belt loomed as the most obvious threat to Comet Atlas, it was not the only danger waiting for this fragile traveller. In fact, the belt's great boulders and rocky fragments, those dramatic hazards we imagine colliding in fiery explosions, were not necessarily the greatest risk. The true dangers were subtler, invisible to the naked eye, and far more insidious. For Atlas, the peril came not just from the possibility of smashing into a mountain-sized asteroid, but from the constant bombardment of smaller unseen enemies, dust grains, micrometeoroids, and swarms of debris that litter the solar system like sand on a beach. Against these countless tiny projectiles, Atlas was defenseless. And in the unforgiving vacuum of space, death by 1,000 cuts can be far more certain than death by a single blow. To understand why these invisible hazards were so dangerous, you need to imagine what Atlas really is. Unlike the rocky asteroids, which are solid chunks of stone or metal, comets are delicate, loosely bound conglomerates of ice and dust. Astronomers often describe them as dirty snowballs, but even that analogy makes them sound sturdier than they really are. A comet's nucleus is more like a pile of frozen rubble, glued together by weak forces, riddled with voids, cracks, and pockets of volatile gases. Its outer crust is fragile, easily fractured, and its core is highly porous, more like packed powder than solid ice. That fragility is part of what makes comets so spectacular. Their outbursts, tails, and disintegrations are direct consequences of their weakness. But it is also what makes them so vulnerable. For an object like Atlas, travelling at tens of kilometres per second through a region filled with dust and debris, even a grain of sand can become a bullet, capable of excavating craters, opening fractures, or destabilising the fragile balance of its structure. The asteroid belt is often portrayed as crowded, but in reality, most of its rocks are separated by vast distances. If you were standing on one asteroid, you wouldn't see another looming nearby. It would be a lonely view of the empty space. But what fills that space, what lingers invisibly between the larger bodies, is dust. Fine particles shed during collisions, fragments of ancient impacts, leftovers from shattered comets. These grains are small, but their numbers are vast, and they are constantly in motion, circling the sun at enormous speeds. Atlas, plunging retrograde through this field, was like a fragile balloon drifting into a hailstorm. A single pebble-sized impact might punch through its crust, releasing internal gas in a violent eruption. Thousands of tiny grains striking its surface could sandblast away its layers, eroding it until it cracked from within. Astronomers studying comets know this danger well. Dust and micrometeoroids are often underestimated compared to the dramatic threats of large impacts, but they are relentless. Over time, they strip surfaces bare, expose hidden ices, and destabilize fragile nuclei. For Atlas, already weakened by asymmetric outgassing and riddled with internal stresses, the constant pressure of these tiny strikes could become the final straw. The asteroid belt didn't need to destroy it with a single catastrophic collision. It could dismantle it grain by grain, slowly but inevitably. And there was another danger lurking in this sea of dust: electrostatic charging. As fine particles of dust interacted with solar radiation and the plasma environment, they became charged, creating electric fields that could influence the behavior of gases around the comet. Scientists speculated that these charged particles might play a role in triggering sudden outbursts, destabilizing jets of gas, or even snapping tails away in disconnection events. Atlas was already showing signs of instability in its tail. Adding dust storms into the mix could amplify the chaos, creating sudden and unpredictable eruptions of activity. For those following Atlas's story, this hidden danger gave the comet's journey an almost tragic inevitability. It had survived billions of years in the deep freeze of interstellar space, untouched by stars or planets, only to find itself unravelling when it finally crossed paths with our solar system. The irony was stark. After drifting unscathed through the galaxy's vastness, its greatest threat came not from grand collisions with giant worlds, but from clouds of dust too small to see with the naked eye. It was a reminder of how fragile cosmic travellers really are, how easily they can be undone not by dramatic catastrophes, but by the steady, invisible grind of tiny forces. And yet, this constant threat was also a gift for science. If Atlas did fragment, if it broke apart under the combined pressures of dust impacts and internal stresses, astronomers would have a rare chance to study its interior directly. Fragmentation, though destructive, can reveal layers that would otherwise remain hidden, exposing the comet's composition from crust to core. We would be able to see not just the gases it vented, but the structure of its very bones, the frozen architecture of a body born around another star. In this sense, Atlas was like a locked chest, fragile, beautiful, and dangerous. Whether it stayed intact or shattered, either outcome promised treasure. But for those who had grown invested in its survival, who saw it as a symbol of endurance, the hidden dangers made its fate feel like a slow-motion tragedy. Every flare of brightness, every disconnection of its tail, every unexplained dimming was scrutinized. Was it a natural cycle of activity, or was it the beginning of the end? Was a dust storm tearing at its surface, or had a micro-impact triggered a crack? The comet became a kind of cosmic patient, monitored for signs of decline, every observation an anxious check for symptoms. The community of astronomers, both professional and amateur, became its caretakers, watching as the fragile body navigated the invisible gauntlet of hazards surrounding it. The narrative deepened when scientists considered the scale of time. Atlas had travelled for billions of years across interstellar space, untouched and pristine, only to reach its greatest peril in the last tiny fraction of its journey. Its survival was a question of days, weeks, maybe months, compared to the vast timeline of its existence. To think that such an ancient relic could endure for eons only to fall apart so close to us was almost unbearable. It made its journey feel fragile, precarious, a thread stretched thin across the ages and now fraying under the pressure of the solar system's invisible storms. For the public, the story of hidden dangers resonated in a different way. It turned Atlas from a distant comet into a symbol of endurance in the face of invisible threats. Just as the small, unseen forces of life often shape our own fates more than dramatic catastrophes, Atlas's peril came not from obvious collisions, but from the constant pressure of countless tiny impacts. Its fragility became a mirror of our own, its struggle a story of survival against forces too small to see yet too powerful to ignore. The comet became not just an object of science, but an emblem of vulnerability, a reminder that endurance is never guaranteed, no matter how long a journey has been. And so Atlas pressed on, through the dust storms, the micrometeoroid clouds, the plasma winds, and the asteroid belt ahead. It had survived longer than anyone could have imagined, carrying its alien chemistry and ancient history into the heart of our solar system. But every step forward was uncertain. Every night of observation carried with it the same haunting question. Would this be the night the ancient traveller finally broke? The hidden dangers were everywhere, and Atlas was fragile, but it kept moving, glowing, venting, blazing its path across the darkness. Its story was not over yet, but the end felt closer with every flicker of its fragile tail. Whenever something mysterious crosses our skies, speculation follows close behind, and Comet Atlas was no exception. From the moment astronomers suggested it was not native to our solar system, but a relic from another star, the public imagination ran wild. If a comet could travel such immense distances, carrying within it the frozen chemistry of alien worlds, then surely it must hold secrets worth more than gold. The questions poured out faster than science could answer them. Was Atlas carrying the building blocks of life from a distant planetary system? Could its unusual chemistry reveal evidence of processes we had never seen before? And the most tantalizing of all, what if Atlas wasn't entirely natural? That last question may sound outrageous, but it wasn't without precedent. Only a few years earlier, Oumuamua had sparked headlines around the world when some researchers suggested its strange acceleration might be explained if it were artificial, perhaps a fragment of alien technology or a derelict probe drifting between stars. Most scientists dismissed the idea as unlikely, favouring natural explanations, but the possibility had captured the imagination of millions. When Atlas appeared, blazing brightly and behaving unpredictably, it was only natural for the same whispers to return. Was this comet truly a random traveller, or was there something deliberate about its path? Was it possible that it was more than just ice and dust? Conspiracy forums buzzed with theories. Some claimed the comet's unusual brightness fluctuations were evidence of controlled manoeuvres, like thrusters firing on a spacecraft. Others argued that its high concentration of carbon dioxide was not natural, but the exhaust of some ancient engine still sputtering after eons in the void. A few went further, suggesting that the very fragility of Atlas was part of a disguise, a shell hiding something within, an artifact perhaps, encased in ice to protect it during its interstellar journey. None of these ideas held up under scrutiny, but they reflected something deeper, the need to make sense of the unknown, to find meaning in a messenger from beyond. More grounded, but no less thrilling, was the speculation about Atlas as a carrier of alien chemistry. Every comet in our solar system carries clues about the early days of its formation, but an interstellar comet is something else entirely. It is a time capsule not from our history, but from someone else's. If comets like Atlas are the frozen remnants of planetary systems, then studying them might give us our first direct evidence of how other stars form their worlds. Did alien comets contain the same water ice that seeded Earth's oceans? Did they carry amino acids, the simple precursors of life, as our local comets sometimes do? If so, then perhaps comets like Atlas are not just wanderers. They are couriers, scattering the seeds of life from star to star, turning the galaxy into a garden where planets bloom with possibility. This idea, known as panspermia, has lingered in scientific discussions for decades. It suggests that life might not arise independently in every star system, but could instead spread through the galaxy, hitchhiking on comets, asteroids, and interstellar debris. If true, then the story of life on Earth might have begun not here but elsewhere, delivered on the back of a frozen traveller billions of years ago. Atlas, with its alien chemistry, became a symbol of this possibility. Was it carrying molecules forged in an alien ocean, trapped in its ices when its home star was young? Could its dust hold hints of biology, even primitive ones, waiting for a laboratory to reveal them? The speculation was irresistible, and though scientists were careful to temper expectations, they admitted that even the tiniest fragment of Atlas would be priceless to study. There were other, darker speculations too. Some feared what such a comet might bring. If comets could carry life, could they also carry death? Viruses, toxins, alien microbes, concepts familiar to science fiction but chilling in the real world, were invoked as potential dangers. Atlas, they warned, might not be a gift but a Trojan horse, carrying unknown threats to any planet it encountered. Scientists dismissed these fears as extremely unlikely, pointing out the harshness of interstellar space and the improbability of survival for complex organisms. Still, the idea lingered in the public imagination, amplified by the comet's unpredictable behaviour. Every sudden flare, every unexpected dimming, every twist of its tail seemed to add fuel to the fire of speculation. Even within the scientific community, speculation took bold forms. Some researchers proposed that Atlas might not have formed in a star system like ours at all, but in the chaotic debris around a dying star or a supernova. Its unusual chemistry could be the fingerprints of violent origins, a relic of catastrophic events that scattered material across the galaxy. If that were true, then Atlas was not just a messenger from another star. It was a messenger from death itself, carrying with it the story of worlds destroyed. The thought was sobering. This fragile comet glowing softly in our skies might be a shard of tragedy from light years away. Of course, most of these speculations would remain just that, speculation. Atlas was too fragile, too unstable, too far for us to send spacecraft in time. We would never hold its fragments in our hands, never taste its chemistry directly, never examine its dust grains under a microscope. All we had were telescopes, spectra, and the fleeting window of its passage. That limitation made the speculation even more intense. The less we could know, the more our imaginations filled in the gaps. Atlas became not just a comet, but a canvas onto which people painted their fears, their hopes, their questions about life and the universe. What made this wave of speculation so powerful was the comet's timing. Humanity had only just begun to recognize interstellar visitors. Oumuamua and Borisov had set the stage, and now Atlas had arrived with a drama all its own. The idea that 3 alien messengers had come so close in such a short span made it feel as if the galaxy was speaking to us, sending signals one after another, daring us to interpret them. Was it coincidence, or was there a deeper pattern? Were we finally beginning to notice what had always been happening? The constant exchange of material across stars, the quiet traffic of the cosmos? For many, Atlas symbolized that awakening, the realization that our solar system is not an island but a crossroads, and so speculation became not just a fringe distraction but part of the comet's story itself. Atlas was fragile, unpredictable, alien, and fleeting. Its very nature invited questions, its very survival uncertain, its tail blazing like a flare calling for attention. Whether people saw it as a messenger of life, a remnant of death, a disguised artifact, or simply a comet unlike any other, the fascination was the same. Atlas had ignited something in us, something beyond science, an imagination that reached for meaning in the unknown. In the end, speculation was not just noise. It was a reminder of how deeply we yearn to connect with the cosmos, to find stories in its wanderers, to believe that these fragile visitors carry more than just dust and ice. Atlas, whatever it truly was, became a mirror of our own questions, and perhaps that was its greatest gift, to make us wonder, to make us dream, and to remind us that sometimes the wildest possibilities are worth holding on to, even if only for a moment, as the ancient traveller blazes past and disappears into darkness once again. The sun had always been the inevitable destination. For Comet Atlas, every twist of its orbit, every outburst of gas, every flicker of instability had been leading to this moment, the final approach toward the blazing heart of our solar system. After billions of years of drifting in darkness, it was now entering the crucible, the region where countless comets have been either transformed into glorious spectacles or reduced to formless clouds of dust. Atlas was fragile, already battered by dust impacts, destabilized by erratic outgassing, and scarred by the plasma storms of the solar wind. Yet still it pressed forward, an alien wanderer plunging toward the star that would decide its fate. For astronomers and skywatchers alike, this was the stage where the comet's story would either reach its triumphant peak or collapse into tragedy. As it drew closer, the sun's heat increased exponentially, not linearly. This meant that every million kilometers closer unleashed dramatically more energy on Atlas's delicate surface. Subsurface ices that had remained frozen solid for billions of years were now awakening, transforming instantly into jets of vapor, spewing gas and dust into space. The nucleus trembled under the pressure, venting chaotically. Each eruption carried the risk of cracking its already weakened structure. Observers knew the truth. The same forces that created the comet's beauty, its glowing tail, its brilliant coma, were also tearing it apart from the inside. It was a paradox written in sunlight. The closer Atlas came to brilliance, the closer it came to its own destruction. This was the moment astronomers had waited for. High-powered telescopes trained their gaze on the comet, measuring its brightness daily, sometimes hourly. Every surge in luminosity was charted. Some days it flared spectacularly, glowing so brightly that excitement surged that it might yet become a naked-eye spectacle visible to millions. Other days it dimmed suddenly, sparking whispers that fragmentation had begun. Each observation felt like watching the last breaths of a patient on life support. The readings on the monitors shifting wildly, no one certain whether the heartbeat would hold or fail. The tension was unbearable. One night Atlas looked alive, roaring with activity. The next it seemed to falter, its tail thinning, its coma shrinking. The public followed the drama closely. News outlets speculated daily about whether Atlas would become the great comet of the century or fade into dust before most people ever saw it. Social media buzzed with amateur images and hopeful predictions. For many, the idea that an alien comet from another star might blaze across the skies felt almost mythic, as though we were witnessing a sign from beyond. And that mythology was amplified by the uncertainty. The comet was both promise and threat, both spectacle and warning, both ancient survivor and imminent ruin. Its story was no longer just scientific. It was cultural, emotional, even spiritual for some who saw in its glow the reflection of our own fragility. But the sun is merciless. The closer Atlas came, the stronger the tidal forces pulling on its nucleus. The sun's gravity tugged unevenly on different parts of the comet, stretching it like taffy. At the same time, thermal stresses built within its porous body as different regions heated unevenly. Imagine a sphere of frozen rubble being baked unevenly, one side cracking as it boiled, the other still holding ancient ices. The result was tension, fractures spreading silently through its core. All the while, gas pockets erupted violently, sometimes blasting chunks of the surface into space. Astronomers knew what they were seeing, the signs of a body at war with itself, a fragile relic trying to endure conditions it was never designed to survive. The question was not just whether Atlas would survive, but how it would fail if it didn't. Comets approaching the sun can disintegrate in many ways. Some fracture into several large pieces, each one continuing on a slightly different trajectory, fading like a family of ghosts scattering across the sky. Others dissolve entirely, leaving behind only a faint haze of dust that lingers briefly before dispersing. A few hang on stubbornly, shedding layer after layer, but keeping a small core intact long enough to round the sun and emerge again. No one knew which path Atlas would take. Its alien chemistry and unpredictable behavior made it impossible to predict. Every possibility was on the table, and every outcome carried profound implications for what we could learn. Scientists compared Atlas to past comets that had dared this journey. Some remembered Comet Ison, hailed as the comet of the century before it disintegrated completely during its solar encounter, leaving behind only a faint streak of dust. Others thought of Shoemaker-Levy 9, torn apart by Jupiter's gravity before crashing spectacularly into the planet in a series of fiery explosions. Atlas might follow one of those paths, or it might surprise us all. What made Atlas different was its interstellar origin. If it shattered, its fragments would provide unprecedented insights into the structure of alien comets. If it survived, even as a faint remnant, it would still be a triumph, proof that an interstellar body could endure the sun's fury. As it approached, the sun illuminated Atlas's tail with even greater intensity. The tail stretched millions of kilometers, shimmering with ionized gases, a luminous banner marking the comet's desperate flight. But close study revealed troubling details. The tail often kinked, twisted, or disconnected entirely, signs that the solar wind was overwhelming the comet's ability to hold itself together. Each time the tail snapped and reformed, observers wondered if the nucleus was still intact or if it was already dissolving into pieces too small to see clearly. It was like watching smoke carried by gusts of wind, never sure whether the fire that produced it still burned. The drama of the final approach was heightened by the clock. Everyone knew the timeline was short. In a matter of days or weeks, Atlas would either blaze gloriously across the sky or vanish entirely, its ancient journey ending in silence. Astronomers rushed to capture every photon of light, every spectrum, every image, knowing that this was their only chance. There would be no second opportunity, no return, no future mission to collect samples. Atlas was a one-time event, a gift, and a tragedy rolled into one. Its secrets would either be revealed now or lost forever. And so the comet drew closer, step by step, orbit by orbit, shedding pieces of itself as the sun's heat gnawed at its fragile frame. For those who watched, the suspense was unbearable. Was this the moment it would flare into brilliance, or was this the moment it would shatter? Each night was a cliffhanger, each observation a revelation. The story of Atlas had become a global drama, watched not just by scientists but by dreamers, storytellers, and ordinary people who looked up at the sky and wondered what it meant to witness such a fleeting, fragile visitor from the stars. In the end, the final approach was not just about the comet's survival. It was about what it symbolized, the fleeting nature of beauty, the fragility of ancient things, the inevitability of endings. Whether Atlas burned brightly or faded quietly, its journey reminded us that even the most ancient travelers are not immortal. They too face their limits, their destinies shaped by forces beyond their control. The sun was not just a destination, it was a judge, a crucible, a final trial. For Atlas, the end was near. Whether it emerged scarred but intact or dissolved entirely, its story had already left its mark on us, igniting wonder, fear, and imagination in equal measure. The final act was underway, and the world watched in anticipation, knowing that whatever happened, we would never forget the fragile alien traveller that had dared to approach the sun. The end came not with a single explosion, but with a slow unravelling, a disintegration witnessed step by step as though time itself wanted us to see every detail of Comet Atlas's demise. For weeks, astronomers had warned that the comet's violent outgassing and erratic behaviour suggested it was unstable, and as it made its final approach to the sun, those predictions became reality. At first, the signs were subtle, small fluctuations in brightness, a tail that thinned one night and thickened the next, faint suggestions in telescope images that the coma had lost its sharpness. To the untrained eye, Atlas still seemed alive, but to those who had followed its every move, the whispers of collapse were unmistakable. The nucleus was no longer a single cohesive body, it was beginning to fracture. When comets break apart, the process is rarely clean. Unlike an asteroid shattering into hard fragments, a comet is a fragile, porous body held together by weak forces. Its breakup is messy, chaotic, and often drawn out, more like watching ice splinter across a lake than a single dramatic explosion. Atlas began to show this in real time. High-resolution images revealed its once solid nucleus had become elongated, stretched into multiple bright knots separated by faint streaks of dust. It was as though the comet's heart had torn into pieces, each fragment still venting gas, each one struggling to cling to its identity as the larger body disintegrated. What had once been a single traveller from the stars was now a small family of glowing shards, doomed to scatter further with every passing hour. The drama of the breakup captured the imagination of the world. Headlines screamed that the interstellar comet was dying before our eyes, that the great cosmic visitor would never become the naked eye spectacle so many had hoped for. Yet in that loss, there was also awe. To watch a comet disintegrate in real time is rare. To watch an alien comet, one that had crossed the gulf between stars, was unprecedented. It was like witnessing the autopsy of a body billions of years old, each fragment exposing layers that had never before seen the light of any star. The tragedy of its collapse was balanced by the privilege of the view. Scientists scrambled to capture every detail. Spectroscopic observations revealed new gases venting from the exposed interiors of the fragments, compounds that had been buried for eons now released in their last moments. These measurements hinted at an even stranger chemistry than previously thought, confirming that Atlas was truly unlike any local comet. Its breakup was, paradoxically, the very thing that allowed us to see deeper into its structure. By tearing itself apart, it was giving us the gift of knowledge. The fragments vented furiously, glowing briefly as they raced along diverging paths, each one a tiny torch in the darkness. But they were fragile, and most would not last long. Within weeks, the brightest knots faded, their gases exhausted, leaving behind only dust that spread into a ghostly trail. For those invested emotionally in Atlas's journey, the breakup felt almost cruel. To imagine a body that had survived billions of years in interstellar space, enduring unimaginable cold and silence, only to fall apart just as it came into view of our telescopes and cameras, it was a heartbreak written across the stars. The comet had travelled across the galaxy, only to unravel in the spotlight, its story ending at the very moment it was most closely observed. The fragility of its existence mirrored our own, a reminder that endurance is never guaranteed, no matter how ancient the traveller, and yet, in its destruction, Atlas became more than a comet. It became a symbol of impermanence, of beauty that burns brightly but cannot last. People began to compare it to Icarus, flying too close to the sun. Others likened it to a candle, flaring in brilliance before flickering out. Some even saw in its story a reflection of civilizations, fragile, fleeting, burning brightly for a time before dissolving into dust. The metaphors flowed as freely as the comet's gases, each one a human attempt to capture the poignancy of watching something so ancient come undone. Astronomers debated the exact cause of the breakup. Some argued it was triggered by thermal stresses, the uneven heating of its nucleus creating fractures that eventually tore it apart. Others believed internal gas pressure had built to the point of rupture, pockets of volatile ice exploding as they were exposed. Still others pointed to its passage through the asteroid belt, suggesting that impacts from dust or micrometeoroids had weakened it fatally. In truth, it was likely a combination of all these forces. Atlas had been fragile from the beginning, its alien chemistry and erratic behaviour signalling instability. The sun's heat and gravity had merely finished the job, tearing apart what time and space had only barely held together. As the fragments drifted, their fates diverged. Some quickly disintegrated into diffuse clouds, spreading into the comet's tail until they were indistinguishable from the dust. Others held together a little longer, venting until their fuel was spent, fading gradually. None survived intact. By the time the comet should have been at its most brilliant, rounding the sun and blazing in the twilight sky, it was gone. What should have been a great spectacle was instead a ghost, a memory of what might have been. For the general public, it was a disappointment, a story of potential unfulfilled. For scientists, it was bittersweet. The data gathered was invaluable, but the chance to study a living intact interstellar comet had been lost. Still, Atlas's breakup was not meaningless. On the contrary, it was perhaps the most meaningful moment of its entire journey. By dying in view of our telescopes, it revealed more than it ever could have if it had simply sailed past intact. It showed us the structure of alien comets, the chemistry of other stars, the fragility of bodies formed in conditions far different from our own. It gave us a glimpse of the traffic between star systems, the constant exchange of material that reminds us the galaxy is not isolated worlds, but an interconnected web. In its fragments, in its dust, in its final gasps of brightness, Atlas left us a legacy of knowledge. And in the hearts of those who watched, it left something more. The image of its glowing shards scattering into the void became a haunting reminder of how fragile everything is, no matter how vast or ancient. Atlas had crossed the stars only to be undone at the finish line. Yet even in death, it gave us something extraordinary. A story, a lesson, a moment of wonder. The breakup was not just an ending. It was the climax of a cosmic drama, one that reminded us that even the most fleeting things can leave an indelible mark. Atlas was gone, but its ghost lingered, stretching across the night sky in a faint smear of dust, a final gesture from a traveller that had carried the weight of the stars. The silence that followed Comet Atlas's breakup was almost eerie. For weeks, telescopes around the world had tracked its every move, each night bringing new images, new measurements, new questions. The comet had dominated headlines, stirred speculation, and sparked global fascination, and then, suddenly it was gone. What had once been a brilliant point of light with a shimmering tail was reduced to a faint haze of dust, too diffuse to see with the naked eye, too fragile to last long. For the casual skywatcher, the story was over. The great alien visitor that promised to blaze across the heavens had instead dissolved quietly into nothingness. But for astronomers, the real work had just begun. The aftermath of Atlas's destruction was not silence but analysis. The fragments, however faint, left behind data in every wavelength of light. Observatories pored over spectra, teasing out chemical signatures from the gases released in its final moments. The results were astonishing. Not only did they confirm Atlas's unusual richness in carbon dioxide, but they revealed other exotic compounds, trace molecules rarely seen in local comets. Some of these were thought to form only under extreme conditions, suggesting that Atlas's birthplace may have been unlike anything in our solar system. Perhaps it had formed farther from its star in colder, darker regions, or perhaps it had condensed in a system with a different chemical balance altogether, a world where carbon dominated in ways it does not here. Its death had given us a glimpse into alien geology, the fingerprints of another planetary nursery written in dust and gas. But there was more than just chemistry to consider. The breakup itself told a story. By modelling how Atlas fractured, scientists could infer its internal structure. The comet was not solid but porous, riddled with voids and weak bonds, its interior more fragile than even the weakest local comets. It may have been older than our solar system itself, a relic from an ancient disk of dust and ice that no longer exists. To think that such a body had survived interstellar travel only to fall apart so close to us was heartbreaking, yet it underscored its fragility. Atlas was never meant to endure the sun's heat. Its entire existence had been shaped by cold and darkness, and in light it could only unravel. In the public imagination, the aftermath carried a different weight. People had hoped for a spectacle, a comet blazing overhead, a cosmic event to be remembered for generations. Instead, they were left with disappointment, the promise of brilliance fading into a wisp of dust. Some shrugged it off, forgetting the comet as quickly as it had appeared in the news cycle. But others lingered on the story, drawn less to the spectacle that never came and more to the poignancy of what had been lost. Atlas became a symbol, a reminder of how fragile beauty is, how even the grandest journeys can end in silence. Social media posts reflected this shift, turning the comet into a metaphor for impermanence, for fleeting chances, for the fragility of dreams. Yet disappointment was not universal. For scientists, the aftermath was one of the most valuable opportunities of the decade. By watching the dust cloud disperse, they could measure how solar radiation and the solar wind interacted with alien material. By tracking the faint trail left in the comet's orbit, they could model how its fragments might spread through the solar system, perhaps even intersecting Earth's orbit in the distant future as a faint meteor shower. Each observation provided new insights, each piece of data a step closer to understanding not just Atlas, but all interstellar comets. And there was a deeper implication. The fact that Atlas had shattered so completely suggested that fragile comets like it may be common in the galaxy. If so, then interstellar space may be filled not just with robust bodies like Borisov, but with countless fragile relics that rarely survive encounters with stars. We may have witnessed the natural fate of most interstellar comets, not long arcs around suns, but disintegration upon first approach. That realization reshaped how astronomers thought about cosmic traffic. The galaxy might be littered with the dust of comets like Atlas, their stories ending in silence long before they are ever noticed. In that sense, Atlas was not unique. It was typical, a representative of billions of travellers too fragile to endure. The aftermath also reignited speculation about what could have been. If we had launched a spacecraft earlier, if we had intercepted Atlas on its journey in, could we have captured samples before it broke apart? Could we have touched alien dust, held it in our hands, studied it in laboratories on Earth? The frustration was palpable. Technology was advancing, telescopes were improving, and yet Atlas reminded us of how unprepared we still are to seize fleeting opportunities. Its breakup became a rallying cry for future missions. Be ready, because the galaxy will not wait. The next interstellar visitor could arrive at any time, and if we are not prepared, we will miss it too. For those who watched Atlas closely, the aftermath was not just about science or disappointment, it was about perspective. Here was a body older than Earth itself, carrying within it the chemistry of another star, drifting silently across the galaxy for billions of years, only to be seen by us in its final days. To witness such a moment was a privilege, even if the outcome was tragic. It reminded us of how small we are, how fleeting our own lives are compared to the lifespans of stars and comets. Yet it also reminded us of our capacity to see, to wonder, to understand. The fact that we could track Atlas, analyse its fragments, and speculate about its origins was itself extraordinary. For a species that had only recently learned to look beyond its own world, this was a triumph, even if the comet did not survive. The dust cloud of Atlas lingered for a while, stretched thin along its orbital path. For a time, telescopes continued to track it, measuring its dispersal, watching it fade. But eventually, even that ghostly remnant was gone, absorbed into the background of interplanetary dust. The traveller from the stars had vanished, leaving behind only data, memories, and questions. Its absence was profound. After months of suspense and speculation, the sky felt emptier without it. Yet in that emptiness lay the realization that there will be others. The galaxy is vast, and Atlas was not the first, nor will it be the last. Its death was not an ending, but a chapter in a story that will continue as long as stars form planets and comets are cast into the void. In the aftermath of Atlas, we were left with more than dust. We were left with humility, with wonder, with a renewed drive to search the skies for the next visitor. We were left with the knowledge that even in death, a fragile comet from another star could change how we see the universe. And we were left with the haunting image of its fragments, glowing briefly before fading into nothingness. A reminder that even the oldest travellers, even the most ancient relics cannot escape the pull of time, the heat of stars, the inevitability of endings. Atlas was gone, but in its absence it left us richer, wiser, and more aware of the delicate threads that tie us to the cosmos. In the end, Comet Atlas's story was not one of triumph or spectacle, but of fragility and fleeting beauty. It arrived suddenly in our awareness, an alien traveller that had wandered for billions of years across the abyss between stars, only to unravel just as it entered our gaze. We had imagined a comet blazing gloriously across the skies, a naked-eye wonder to rival the great comets of history. What we witnessed instead was something more haunting, a slow dissolution, a body undone by its own chemistry, battered by dust, torn by plasma storms, fractured by heat, and stretched to breaking by the gravity of the sun. And yet, in its failure to dazzle, Atlas revealed something far more profound. Its death was not a disappointment, but a revelation. By breaking apart, Atlas allowed us to see deeper than we ever could have if it had remained whole. It exposed its chemistry, its structure, its fragility. It told us about the diversity of worlds beyond our sun, about how alien planetary systems may forge their comets differently from ours. It gave us clues about the building blocks scattered through the galaxy, about the traffic of ice and dust that ties star systems together. Even in dust it spoke, even in silence it left echoes. Atlas reminded us that the universe does not owe us spectacles. It owes us truth, and sometimes truth arrives not as brilliance but as dissolution. The comet's journey was also a mirror, reflecting our own place in the cosmos. It showed us how fleeting and fragile even the oldest things can be. Here was a body older than Earth itself, undone in mere weeks. Its story was a reminder that endurance is never guaranteed, that age is no shield against the inevitability of change. We too are fragile travellers, caught in forces far larger than ourselves, vulnerable to endings we cannot predict. Yet like Atlas, we leave trails behind, data, stories, memories, that persist even after we fade. In this way, the comet was not just an alien messenger, it was a metaphor, a cosmic parable about impermanence. For science, Atlas was a milestone. It was the third interstellar visitor we have ever seen, and the strangest. Its chemistry forced us to revise models. Its instability forced us to reconsider what interstellar comets might look like, and its death forced us to accept that fragility may be their most common fate. It became a rallying cry to prepare for the next one, to be ready with spacecraft, with instruments, with missions that can seize the opportunity before it slips away. Atlas's legacy is not just in the data it gave us, but in the urgency it inspired. The realization that we live in a galaxy filled with wanderers, and that each one is a fleeting chance to learn something extraordinary. For the rest of us, Atlas left behind wonder. Even if it did not blaze in the sky, even if its story ended in dust, it still stirred imaginations, still made millions look up and think about the traffic between stars, about alien worlds, about the possibility of life carried in frozen fragments across the galaxy. It made us speculate, dream, and feel awe at the scale of the cosmos, and in that sense it succeeded. It did not need to become a great comet to leave its mark. Its story was enough. So now Atlas is gone, dispersed into a thin haze along its orbital path, its fragments lost to time, but the questions it raised remain. What other worlds gave birth to bodies like it? How many more wander between the stars unseen? And what will the next visitor bring? A mystery like Oumuamua, a steady messenger like Borisov, or another fragile ghost like Atlas? The answers are waiting in the skies, and Atlas's greatest gift may be that it prepared us to look harder, to wonder deeper, to be ready when the next traveller arrives. The conclusion of Atlas's journey is not really an ending. It is a reminder that the universe is alive with motion, with stories, with encounters that shape our understanding of where we come from and what we are part of. A reminder that beauty can be brief but still meaningful. A reminder that even in death, a fragile comet can change how we see the stars. Comet Atlas may have burned too briefly to become legend in the skies, but in science, in imagination, and in memory, it will endure. It lived for billions of years unseen, and it died in our light, leaving behind not brilliance but meaning, and perhaps that is the greater gift.